Question 24. The diagram shows a shape formed by an isosceles triangle ABC joined to a semicircle with diameter AB. The question says find the perimeter of the shape. We have to find the perimeter of this shape. And it said that you have an isosceles triangle, that is, these two sides are equal. This is 13 and this is 13. And we are also given the vertical height of the isosceles triangle, which is 12. We are also told that we have a semicircle, that this is a semicircle, and we're asked to find the perimeter of the shape. To do this is quite easy, but there are some technicalities in solving this. It's just straight. Perimeter means adding all the external sides. So we're adding 13 plus 13 plus the length of the arc. That forms the perimeter of the shape. We already have two of them. We have AC, that's 113. We have length of BC, that's another 13. But we need the length of the arc. And to get the length of the arc, we need the radius of the semicircle. And with the radius, we calculate the length of the arc. The radius is not given to us. We need to find it. Considering this isosceles triangle, we have the vertical height of the triangle as 12, making a 90 with the base of the isosceles triangle. And with this 12 and one of the 13s, you can find the radius. Let's say this point is point O. The radius runs from point O to point B or from point O to point A. If you're good enough, you'll be able to identify this right angle triangle. And with the right angle triangle, you can find line OB or OA, which is the radius. So let's find it. For you to really understand by visualization, we'll draw right angle triangle COB. You have this dotted line. Let's just make it a straight line. This is C, this is O to B. Then you join with a slanty line. This is your right angle, and this part is 12 and this part is 13. And we're looking for the radius, which is here, because the radius runs from the center to one end of the circle or the semicircle. Now with this right angle triangle, we can find the radius. What will help us solve this is Pythagoras theorem. When you have a right angle triangle, you're having two of the sides and you're looking for the third one, you apply Pythagoras theorem. But the most important side of the Pythagoras theorem in this case is identifying the hypotenuse. So we know the hypotenuse is always facing the 90. This is angle 90, this is the right angle. 13 is there for the hypotenuse. The 12 could be the opposite or could be the adjacent, depending on the acute angle given to us. If it's at C, 12 is the adjacent and R is the opposite, because the side facing the angle is the opposite. And if it were angle B that was given to us, the side CO, which is 12 centimeters long, will be our opposite. But in cases like this, all you need to identify is the hypotenuse. Next, the formula we're applying is hypotenuse square equals opposite square plus adjacent square. We're looking for a side. Let's say the side we're looking for, let's say it's opposite. If you're looking for any of the shorter sides, you have your formula as hypotenuse square minus either adjacent or opposite square should equal, in this case, the opposite square. So you have opposite square equals hypotenuse square minus adjacent square. The hypotenuse is the longest side, so when you're looking for any of the other two short sides, you will just do the hypotenuse square minus the side you are given square should equal the side you are looking for square. Our opposite is R in this case, so we have R square equals, the hypotenuse is 13, so we have 13 square minus the adjacent in this case is 12, so we have 12 square. So we have R square equals 13 square, that's 13 times 13, that's 169, minus 12 square, which is 12 times 12, that's 144. R square equals 169 minus 144 will give you 25. We're looking for R, and this R is squared, and we need to get the square of the R. So we introduce square to both sides. You have square root of this and square root of this. The square root cancels the square in this case. You have R equals square root of 25 in this case is 5, because we're working with positives, so we can't have plus or minus 5. So we have the radius is 5 centimeters. Now we know line OB, which is the radius, is 5 centimeters. With these 5 centimeters, we can find the length of the arc of the semicircle, which will help us in getting the perimeter of the shape. And there are two formulas you can apply. You can either apply the formula for the perimeter or the circumference of a circle, which is 2 pi r Since this formula is for a full circle and this is a semicircle, we now divide it by 2. So we have the perimeter of a semicircle as 2 pi r over 2. Now we can break this down. You can say 2 cancels 2. You'll now be having the perimeter of a semicircle as pi r. Or we can apply the formula, it also works. That's theta over 360 times 2 pi r. This formula would be very useful when you have part of a circle that is not a semicircle and it's at an angle, for example at angle 60. If it were in this case, let's say for example this is 50 degrees, we can apply this formula to find the length of the arc, which is theta over 360 times 2 pi r. That's 50 over 360 times 2 pi r. But in this case, since it's a straight line, your theta or your angle is 180 degrees. That's angle on the straight line. This is the straight line and this is the angle. That is, this angle here is 180 degrees. So you can also apply this formula using 180 as your theta. Using this first formula and taking pi to be 3.14, which in fraction is also the same thing as 22 over 7, you have 3.14 times your radius is 5. Remember that OB is 5 centimeters. That equals the perimeter of a semicircle. The perimeter of a semicircle is 3.14 times 5. That gives you 15.7 centimeters. We now know the length of the arc is 15.7 centimeters. That's 15.7 centimeters. To find the perimeter of the shape, we have line AC plus line BC plus arc AB. That's this arc AB should equal the perimeter of the shape. So we have 13 plus 13 plus 15.7. You know, you're allowed to use a calculator. 13 plus 13 plus 15.7 will give you 41.7 centimeters. That's the final answer. So the answer to the question is 41.7. They've included the unit, that's centimeter. Be careful, if you don't have the unit at the back, make sure you include the unit in your answer. Now, going back to this part, where we're trying to find the length of the arc. You know, we said there are 2 formulas you can apply. You can either apply this, where you have 2 pi r over 2, which is also the same thing as that's 180 times 2 times 3.14 times 5. Then divide your result by 360 pi r, or the length of arc of a semicircle. We can also apply this formula when you have your angle, that's theta over 360 times 2 pi r. And since in this case it's a semicircle, you have your theta as 180. So you have 180 over 360 times 2 times, you can take your pi as 22 over 7 or as 3.14 times your radius is 5. You can either choose to say 180, 181, 180 in 362, or you multiply the numerators. 180 times 2 times 3.14 times 5 will give you 5,652. We divide it by 360. Divided by 360 will give you 15.7. That's the answer is 15.7 centimeters. You can now see we have the same answer. So it's important you learn both ways of finding the length of an arc, because you might have a question that might not be a semicircle and might be of an angle. A situation where you have to apply the second formula and the first formula won't work.